All right, and we're moving on with Unit 3, and we're going to take a look at writing equations from real-world situations. You can see that that's standard 7.1 to 7.4. All right, I can write the equation of a line given information for various contexts. I can write equations of absolute values for various contexts, exponentials, quadratics. That encompasses all four of our functions. So the good news is there's nothing really new to teach you, right? So if you look at our function key, right, we're still writing the equations of our four functions here. All right. So when we do that, we still need the same information that we've been using, right? Whether that's from a graph, whether that's from a table of values, we still have to find those key pieces that go into our equations. So now the difference is now we're going to extract that information from words. So we have to pay attention to key pieces, all right, of the problem, all right, as we read through it. So we're going to do that with this particular lesson. And what we're going to try to do is incorporate some things that we've already talked about. And so we're going to try to draw pictures, right? Draw a graph to help us visualize everything, all right, and label that. You might want to get a highlighter out or at least another color pen, maybe to underline or circle some keywords as we read through some of these problems. So once again, let's jump down, all right, to problem 1 here. Okay, so due to a drought, the canal from a reservoir is open so that the reservoir is lowered to meet the irrigation needs for farmers. The level of water is being lowered by 15 feet per day until it hits its lowest point at 85 feet after 5 days. Then the water level begins to raise at the same rate it is being lowered. All right, so now when I see this, all right, I see some key phrases here. So it's being lowered by 15 feet per day, all right, and then it also has its lowest point, the lowest point at 85 feet after 5 days. All right, and then the water level begins to raise at the same rate it was being lowered. Raise at the same rate it was being lowered. Okay, so now when we see all of that, all right, we translate that into, okay, what key pieces of a graph or a function could that represent? Now, some of you might get this just from reading this, but now notice if I draw a graph to model this situation, all right? So let's do this. All right, so when we talk about it, we're starting at some height, the water level at some height, and it is lowered, right, at a constant rate, that 15 feet per day. All right, so when you hear per day, per hour, per month, per whatever, that's typically a constant rate of change. So it's lowered, all right, at 15 feet per day, all right, until its lowest point at 85 feet. So it's going to go down, and it's going to hit its lowest point. And what we know is that it happens at 5 days, and we know that that height is now 85 feet, right? And then what we know is that then the water level begins to raise at the same rate it was being lowered. So now it's going to hit that low point after 5 days, and then it's going to go back up at a constant rate of change. And so notice once I draw this, all right, and I take this information and translate it into a visual that you should hopefully be able to recognize, we see that it is in fact, right, an absolute value function. All right, so what type of function is this? It's absolute value. All right, how do we know? All right, we know a couple of things, right? We know it has a turning point, right? And when we see that phrase, lowest point, highest point, right, that typically is indicating that we have a turning point. It's changing direction, okay? And we know it has a constant rate of change in both directions. So we see those key pieces that we've been recognizing, all right, in our tables of values that we've seen in our graphs, right? And now we're just translating that. So 15 feet per day, the lowest point at 85 feet after 5 days. So when I look at this, right, I can see that I go down negative 15 feet per day, and then I go up 15 feet per day. So there's that plus or minus, right? Then after 5 days, I'm at 85 feet. And typically, when you're working in problems, time is the x-axis, all right? And so you may assume that. So now notice, now can I take that information and represent the situation? So if I think about our model, right, a x minus h plus k, right? So we know what the hk is, right? That's going to be the 5, comma, 85. So x minus 5 plus 85. Now, once again, we have our two rates of change, negative and positive. Well, our absolute value graph opens up, so that means I want the positive rate of change. So I want the 15 over 1, or just the 15. All right. So now, once we have our equation, right, now we're going to do a little bit of predicting. What will the water level be after day 7? All right, and so what we can do is we can just take 7 and plug it in for x and see what the height would be. All right, so y equals, and 15, 7 minus 5 is 2. Absolute value of 2 is 2. So remember, you have to take the absolute value of that number before you perform the operation on the outside, which in this case is multiplication. 15 times 2 is 30. All right, and then 30 plus 85 is 115 feet. All right, now notice we could also figure that out with some common sense, right? We know at day 5 it was at 85 feet, and then I know it's going up 15 feet per day. So at day 6, I add 15 feet on, that would be 100. At day 7, I add another 15 feet on, that would be 115. So you could use the common sense to verify, all right, the algebra that you just did in this particular problem. All right, so let's take a look at another one. Let's flip the page here. All right, okay, yeah, you want to buy a Tesla Model S. They offer a payment plan that requires $6,000 when you purchase the car. Then you pay a monthly fee of $1,050 each month to work towards paying off the rest of your car. All right, so draw a model, all right, draw a graph to model the situation. So let's identify some key things here. So requires $6,000 when you purchase, all right, and then a monthly fee of $1,050, all right. Okay, a monthly fee. All right. So now when we talk about this, right, that monthly fee, that once again seems like a constant rate of change, right? Now, when we're paying something off, right, we had to pay that $6,000 right away, right, to walk out with our Tesla. You had to pay that down. And then each month we're going to pay $1,050, and that's going to remain constant until we have paid off our car. And so what you can see is that this really is a linear function, right? Okay, so why is this linear? All right, we have a constant rate of change, right? And this time there is no turning point, right? It's not going to change direction, right? We might end, right, but we're not going to start paying less, all right, okay, than our monthly fee here. All right, so now write an equation. Now, once again, when we go back to our, right, our model here, right, we need two things, and I'll write it right below here. We need a rate of change, right, a constant rate of change, and we need a starting point. Now notice this is our starting point here. So notice that would be 6,000. All right, so at time 0, because that's the very beginning, right, you had to pay $6,000. And then we're paying that $1,050 per month. So if I plug all that in, so that's $1,050, that's our rate of change, and then x minus 0 plus 6,000. Now, if you want to, we don't have to write the x minus 0. You could have just written this as 1,050. Well, I did not write that right. 1,050x plus 6,000. Either way is totally acceptable. Now, how much would you pay after 12 months, right? So y would equal to 1,050 times 12 plus 6,000. All right. Okay, so 1,050 times 12 would be 12,600 plus 6,000. So y would equal to 18,600. So you would have paid $18,600 after the first year total, all right, towards paying off your Tesla. All right, let's look at one more problem here. Let's look at problem 3. All right, the population of microbacteria starts at 1 gram and triples every day. All right, now starts at 1 gram, okay, and triples every day. All right, triples every day. So there's our rate of change. And when we say something's tripling, right, we know that that means multiplying by 3. And recognizing that, all right, should help us know what type of function this is, right? So anytime we're dealing with a multiplier divider, we know that that is going to be an exponential function, right? So we know this has to be exponential, and that's because we have a multiplier for our rate of change, right? Now, let's talk about the equation, right? So y equals b to the x plus k. Now, so since it triples every day, we know b is 3. So that's going to be 3 to the x. Now, the trick to this is figuring out what your k value would be. And this is where the graph will help you. So notice if I draw my graph, it says we start at 1 gram. So right there is 1. All right, so that's 1. and it triples every day. So then it's going to go up and just triple and get bigger and bigger and bigger every day. Now, if you think back to what we did with our graphs, all right, we always said the y-intercept is one step above our floor. And so notice when I start at 1 gram, that is my y-intercept, that is 0, 1. All right, so now if I think and we're working reverse, well, my y-intercept is 1 above my floor. This time I have my y-intercept and not my floor. All right, so that means my floor has to be 1 below, which means my floor would have to be 0. All right, so plus 0, or you can just write y equals 3 to the x. Okay, either one of those would be acceptable. So notice we're still using the same information we would have if we were doing something graphically, right? But now we're just working in reverse. So we should be able to kind of flip that process going back and forth. Okay, how much bacteria will there be after 8 days? Well, we just want to do y equals 3 to the 8th. Now, once again, just as a little bit of a review, right? So let me clear this out. This caret key, this is what you're looking for. This is your power key. So if I want to do 3 to the 8th, notice when I hit that key, it gives me an exponent. So make sure before you hit enter that you see that the 8 is above, right? Or that you see this little symbol before the 8. Hit enter. And what that tells me is that my bacteria population has grown to 6,561 after 8 days. All right, so there's your introduction to writing equations from real world situations. We'll do a few more problems in class next time. All right, so have that ready to go, and I'll see you then.